technician here with a short little video discussing the chronograph project that getting started a thread on crazybuilders.com. A lot of people make these air cannons and so forth, and there's not too much data on, well, just how fast they are, because not very many people have a shooting chronograph unless you're really into paintball and have invested the money in one. So this project is in regards to trying to use a laptop computer and a few extra parts to build something that can actually measure high-speed flight of objects, whether it be potatoes or your other favorite projectiles. The project's based on a couple of photo transistors. If we know the way to do the math, we can figure that speed is equal to distance divided by time. That if you don't remember that, the easy way to remember it's like if you're driving your car. For those overseas out of the US, you can substitute kilometers per hour. But speed is equal to distance traveled in a particular time, so it's divided by time. So 60 miles an hour, if you were traveling that, you'd get 60 miles away in 1 hour. If you shorten the distance, because we know miles is miles, and shorten it to 1 mile, we'd figure that it would take 1/60th the time. There's 60 minutes in an hour, so that would easily change down here to 60 miles an hour is the same as 1 mile in 1 minute. That could also be measured as 1 mile a minute. A lot of stuff that we measure, like for paintball, is measured in feet per second. So our distance is given as a foot. In paintball, most places they regulate you to a maximum of 300 feet per second. We're trying to get marshmallows and stuff a little bit faster than that. Our project is to see if we can get marshmallows supersonic. Speed of sound is about 1130 feet per second. That is quite a bit faster than you're allowed with paintballs on a paintball court, because it can be damaging. So this, if we figure that speed of sound and figure how long would it take to travel 1 foot, the same way we convert 60 miles to 1 mile a minute applies. Thousandths of a second is called milliseconds. So speed of sound is 1 foot and 0.000909 seconds roughly, or about 0.9 milliseconds. That we should be able to detect with a photo transistor. I have a bunch of photo transistors that I picked up surplus. They are fast enough to detect that frequency, because a lot of those will work at much higher frequencies than that. If we know the distance and find a way to time it, that's where the laptop comes in. Most people don't have fancy high-speed counting stuff, but most laptops and other equipment have sound cards. And these speeds, if you figure 1 millisecond, if you had that as a continuous cycle, that's only 1,000 cycles in 1 second, or about a kilohertz. Most sound cards can record that just fine. So with that in mind, we were thinking there would be a way to space 2 of these accurately, a foot apart, because we don't want our distance to become a problem. If we build this, we can either go with English units using English tape measure, or if you're into metric, how many meters per second, you can use a metric measure. And for rigidity, I was going to use a piece of ABS pipe. I've marked off 2 bands here, a foot apart. Verify that that's a foot apart. And then with the holes that's in it, I can add light sources. I can add the photo transistors. We can light up marshmallows as they go by, and feed the output from photo transistors with a battery and a bias circuit, and try to figure out just how fast we're getting marshmallows. So if you get a marshmallow up to speed, currently the only way I have an idea of how fast a marshmallow is going is when I have it impact something like a pop can. The impact was here. It dented the can enough that it tore the metal and the can shredded itself. So that's what the video is about is, gee, how fast is those marshmallows actually launching at? So, we're going to see if we can get some marshmallows supersonic and verify it with a laptop.